A very good evening, friends. Just the continuation of yesterday's class. So, yesterday we have just started with the NCERT summary, or I should say, somewhere we were talking about how exactly we should approach this NCERT books. I already told you, even yesterday I was insisting on this fact that NCERT, my dear friends, is not the source of question, but always regard that NCERT is a source of knowledge. Okay. So having said that, yesterday's class, somewhere the 6 units superficially we talked about, right? It means unit 2 and unit 3 we talked about. Unit 2 I said for preliminary examination, it is very, very important. And unit 3, yes, I cannot neglect this for preliminary examination, but very important for mains examination. Somewhere, minerals and rocks, particularly, I understand they are very, very important. But when it comes to this unit 4 and unit 5, that is from chapter 8 to chapter 14, if I just take it, I understand that they are very, very important when it comes to both preliminary examination as well as mains examination. Okay, right. So climatology and oceanography. Maybe NCERT do not use this word called as climatology. It uses only this word climate. Okay. So this climate and water, that is oceans, they are very, very important. Of course, I'll also show you some specific statements. Even in 2023, this year they have asked questions, and some of these statements I can directly interpret with the statements that is given in NCERT. Okay, right. So having said that, I'll just start with this chapter 8 under climate. I'll just start with this composition and structure of atmosphere. See, even you remember, right? Even we talked about this origin and evolution of this earth. While discussing about this origin and evolution of this earth, that particular chapter was also talking about the evolution of atmosphere and the evolution of oceans. But very briefly, it was talking about. Okay. So here, I'll be talking about, say for example, a detailed fashion. Okay. Now here, under this climate, what exactly this unit deals about, that also say, for example, somewhere they have given it. Okay, right. Now, some of the very basic facts also I'll highlight it, whatever it is important, right? See, my dear friends, when I just talk about atmosphere, once you read this atmosphere, right, one very important fact it says, I know that atmosphere generally extends up to the height of 10,000 kilometers. But what I should understand, see, the statement says 99 percentage of atmosphere is actually confined to what? The first 32 meters itself. Okay. So remaining, even if I just take, say, for example, 9,968 kilometers, what I have is only 1%. And somewhere, this fact also says that I do not have a clear-cut demarcation of this atmosphere. Okay. So there is no concept of perfect vacuum in the atmosphere. Okay. Right, my dear friends. Right. Now, having said that, when I talk about composition of this atmosphere, my dear friends, right? What are the major gases that is there in atmosphere? Somewhere it talks about. Okay. And I also told you whatever it is given in this italics, right? It is very, very important. Okay. Right. So it says carbon dioxide is meteorologically a very important gas and it is a transparent to incoming solar radiation, but opaque to outgoing terrestrial radiation, right? It absorbs part of terrestrial radiation and reflects back some part of it towards the Earth's surface, and it is largely responsible for the greenhouse effect. So, somewhere they are giving you a hint what exactly is the role that is played by carbon dioxide and not thing. When I talk about carbon dioxide, my difference, normally, say for example, this is a situation where we demonify carbon dioxide, right? Normally, say for example, we give an impression as though carbon dioxide is a demon, but not exactly. If carbon dioxide would have not been there, if carbon dioxide would have not been there, this earth would have been extremely cold, right? One study says if carbon dioxide would have not been there, the temperature of the earth will be somewhere around 33 degrees centigrade lower. Okay, 33 centigrade lower. It means today the average temperature of the earth is somewhere around 15.2 degrees centigrade. Assume that it is 15 degree. If carbon dioxide would have not been there, the temperature of the earth would have been somewhere around minus 18 degrees centigrade. So NCERT also explained what is the role that is played by carbon dioxide. Carbon dioxide plays a very important role in maintaining the temperature of the earth. Apart from, say, for example, carbon dioxide, it also talks about water vapor, right? It also talks about water vapor, right? Dust particles, etc. Right? But only thing is that when talk about, say, for example, apart from, say, for example, these gases, my dear friends, right? These gases, right? There are other gases also which is part and parcel of, say, for example, excuse me just a minute. Okay. There are other gases also which is part and parcel of atmosphere, right? This particular chapter has not given, say, for example, the details of the same, right? But somewhere, right, later part also we'll just add the same. Okay. So it says atmosphere composed of gases, water vapor, and dust particle. The proportion of gases changes in the higher layers of atmosphere in such a way that oxygen will almost be negligible quantity at the height of 120 meters, sorry, excuse me, kilometer. So it means in fact says that, say for example, if at all, if I'm just talking about oxygen, I'll be finding oxygen till the height of what, 120 kilometers. Similarly, when talk about carbon dioxide and water vapor, normally you find it only up to the height of 90 kilometers from the surface, right? But let me add some of the other facts which is not given here, my dear friends. When I talk about the composition of atmosphere, if you ask me what is the single largest gas in atmosphere, if you ask me, obviously you know the fact that nitrogen, what percentage it occupies, if you ask me, approximately 78%. Apart from nitrogen, what else you have? You have oxygen. Oxygen occupies 21%. Very interestingly, carbon dioxide, very important gas. I'm not denying the fact. Carbon dioxide occupies only 0.036%. Carbon dioxide is the fourth largest gas in atmosphere. Then comes the question, which is the third largest? There is a gas called as argon. Argon occupies somewhere around 0.93%. It means, see, 1, 2, and 3 gases alone occupies what percentage of atmosphere? If you ask me, it occupies somewhere around 99.93%. But interestingly, nitrogen, oxygen, and argon do not play any climatological role. Neither they can determine the temperature of a place, nor they can influence the, say for example, nor they can influence the moisture content of a particular place. So normally they say, see, they have their own important role, but only thing is that the point what I'm just trying to convey, they do not have any climatological role. Okay, right. Right, my dear friends. Having said this, composition of atmosphere, then comes, say for example, structure of atmosphere, right? You have different layers in atmosphere, okay? See, for example, normally you can take the extent of atmosphere till the height of, say for example, somewhere around 10,000 kilometers, okay? Right. What are the different layers? You know, right? Like the layers what we have in Earth's interior, right? Atmosphere also has a different layer. How do you say that, okay, these are the different layers? Because each and every layer's property is different, okay? In that way, my dear friends, the lowest layer you call them as what? Troposphere. Then I have stratosphere. Then I have mesosphere. Then I have what? Thermosphere. Above thermosphere, I have exosphere, okay? I have exosphere. Maybe if you want to remember, okay, if you're asking me how to remember this, let me tell you, trust me in the exam. When I say trust me in the exam, I'm not asking you to trust me. This is a code word. TR, troposphere, ST, stratosphere, ME, mesosphere, again TH, thermosphere, EX is what? Exosphere. Okay. See, somewhere making a code word, it is not needed. But if at all, if you feel that it is very, very important, going for a code word is right, nothing wrong. Right? You can go for a code word if needed. Okay, now here, otherwise also you can remember. For example, my dear friends, if I talk about exosphere, name itself says I am somewhere away. Am I right? Exo, away. Am I right? Something like that. Meso means middle. Meso means middle. So exactly the middle layer will be what? Mesosphere. Outer layer will be exosphere. Only thing is that I have to remember troposphere is very important. Because last year's mains examination, if you ask me, I'll show you the question also. What exactly they have asked, I'll tell you. They've exactly asked this question, right? I'll show you the question also. (2022) mains examination, this was the question that was asked. Okay, what is the question that was asked, right? Statement says troposphere is a very significant atmospheric or atmosphere layer that determines weather process. How? Okay, somewhere you have to talk about some of the very significant role of or role that is right. Say for example, that happens in troposphere. What are the different atmospheric process, right, that takes place in troposphere? Somewhere you have to talk about. See, let me tell you, troposphere is called as weather layer of atmosphere, or you call them as what? Weather layer of the earth. Very, very important layer. See, whenever I say atmosphere, I say climate, right? If you ask me what exactly is the climate, climate is nothing but what? An atmospheric condition. Now again, if you insist, what condition, which condition, say for example, condition of which layer I am talking about, if you ask me, actually I am talking about the condition of what? Troposphere. To be very practical, we are actually talking about the condition of what? Troposphere, my dear friends. Okay, right. Now, having said that, right, they have given, say for example, the troposphere, only the small correction. In NCERT, they have given the average height of troposphere, but I should understand, troposphere do not have one uniform height. Once you read this paragraph, you will understand, right? The height of troposphere may vary anywhere between 8 kilometers to 18 kilometers. It varies anywhere between 8 kilometers to 18 kilometers. Okay, but on an average, if you ask me, the troposphere average height is somewhere around 13 kilometers. Okay, right. Now, my dear friends, I've already told you this question was directly asked in mains examination, right? If that is the case, the crux of this layer I have to take it, right? So I'm reading it separately. Troposphere is the lowermost layer of this atmosphere. That's okay. The average height is 13 kilometers and roughly extends up to the height of 8 kilometers near the poles and 18 kilometers at equator. Okay, right. The thickness of troposphere is greatest at equator, right? Because it is, say for example, it is greatest. Okay, thickness of troposphere is greatest at equator because heat is transported to the great heights by strong convection. Wherever temperature is very high, air mass will be rising, right? And when air mass rises, obviously I understand the tropopause will be extended. Okay, fine. As I read it, if you ask me what is the most important character of troposphere, if you ask me, I would say it is very popularly called as normal lapse rate, right? This is the most important property of this normal lapse rate. What is this normal lapse rate, my dear friends? Very simple. I know one thing. You increase the height in troposphere, what will happen to the temperature? Temperature will decrease. Normally, what rate, if you ask me, the temperature in this layer decreases at the rate of 1 degree centigrade for every 165 meters of height. Some other books you read it, right? They would have given for every 1 kilometer you increase the height, the temperature will reduce by what? 6.5 degrees centigrade. Okay. So there is a basic difference, right? Book to book, slightly, right? The way how they express will change. But very interestingly, if I convert 165 meters, say for example, to 1 kilometer, right? I may not, say for example, get the exact value. Okay, whatever it is the case. What NCERT says, according to NCERT, every 165 meters you ascend, you increase the height. Am I right? It means when you go to a tall building, right? Something like, say, for example, this Burj Khalifa, assume that the height of the building is more than 1 kilometer. If you're there in ground floor versus the top floor, my dear friends, there will be a difference of somewhere around 6.5 degrees centigrade between the floors. Okay, so as you increase the height, the temperature will decrease. That's what very popularly you call them as what? Normal lapse rate. Very, very important property of troposphere. Okay, see this particular topic, okay, what I'm just discussing, structure of atmosphere, take it for granted, any competitive examination, this particular topic is very, very important. Okay, right. Then my dear friend, stratosphere. Stratosphere is found about tropopause. Diagram itself says. Okay. And what is very important, my dear friends, this is a layer where you have the presence of what? Ozone. Right? And it also says that ozone absorbs ultraviolet radiation and shields life on Earth. To be very precise, Normally we say, right, ozone absorbs harmful ultraviolet radiation, right? That's the reason wherever you have this ozone hole, the insulation may not be filtered, right? The skin related disease and others, say for example, it may result in cancer also sometimes. Okay. So ozone is a protective layer, right? So which layer we have the presence of ozone, if you ask me, ozone is present in what? Stratosphere. Okay, right. Then my dear friends, then comes the next layer. This next layer you call them as what? Mesosphere. So mesosphere lies above stratosphere, right? From 50 kilometers of height to 80 kilometers of height. Okay, that's where I have the presence of what? Mesosphere. Okay, right. And upper limit of any layer you call them as what? Pause. Troposphere upper limit, tropopause. Stratosphere upper limit, stratopause. Similarly, mesosphere upper limit you call them as what? Mesopause. Okay. Then comes ionosphere, my dear friends. See, one small clarification between NCERT and other books when I talk about it. Okay. Here it says ionosphere, right? Right up it is given as ionosphere, but image it talks as what? Thermosphere. Okay. When you read the paragraph it is mentioned as ionosphere, but when you read the image, it is given as thermosphere. If you ask me that the ionosphere and thermosphere are they both same, if you ask me, answer is no. They are not same, right? There is a greater degree of overlapping, or I'll say from 80 kilometers to 400 kilometers, if I take it, yes, this layer is ionosphere. But from 80 kilometers to 700 kilometers, if I take it, then I call this layer as what? Thermosphere. It means till 400 kilometers, ionosphere and thermosphere overlaps. 400 to 700 kilometers, it is only what? Thermosphere. Okay, right. So, but NCERT has not given that. The larger clarity it is not given, but only thing is that the word ionosphere is given. Okay, right. Right, my dear friends. Having said this, okay, right. Name itself says it contains electrically charged particles known as ions, and hence it is known as ionosphere, right? Then it says radio waves transmitted from Earth are reflected back to the Earth by this layer, right? And now they are justifying this thermosphere. Temperature here starts increasing with height. So every layer, my dear friends, what is very important here? Troposphere, you increase the height. You increase the height, temperature will decrease. Stratosphere, interestingly, you increase the height, temperature will increase. If you ask me what is the reason for it, reason is ozone. Then you come to mesosphere. Mesosphere, you increase the height, temperature decreases. Thermosphere, you increase the height, temperature increases. It means there is an alternate sequence of temperature getting reduced and temperature getting increased. Okay. And the name again gives you a clue. Among all the layers you take it in atmosphere, which is the most warmest layer if you ask me? Thermosphere is the warmest layer. Okay. Provided you should have a medium to absorb this temperature. And finally, right, you are there in the outermost layer. The uppermost limit, outermost layer, you call them as what? Exosphere. Okay, exosphere. This is the highest layer, but very little known about it, right? Whatever contents are there, they are extremely rarefied, right? Negligible amount, right? In this layer, and it gradually merges with the outer space, right? Fine, my dear. So, what are the different layers and what exactly is the basic property of each and every layer is given. But let me tell you very frankly, if you ask me, is this, say for example, okay, fine. Is this particular segment enough for me for the examination? If you ask me, obviously I would say no, right? Right. This alone, say for example, composition and structure of atmosphere, there is a limitation. There are n number of, say for example, facts about this atmosphere, composition and structure, they are not given. Okay. They have not ventured, even say for example, what gas, what percentage, they have not given right at this chapter, but still it gives you a basic idea. Right. Now going to the next topic, my dear friends. Next topic. You call them as what? Solar radiation, heat balance, and temperature. And let me tell you, this is one statement or this is one chapter, say for example, from where this year particularly, there we have answered somewhere around 2 questions. Whereas, say for example, this particular chapter alone, somewhere we can answer this Question. Okay. Solar radiation. Solar radiation means insolation. Then they talk about heat balance. Heat balance is nothing but what? The balance between what is incoming and outgoing. Then they talk about temperature, atmospheric temperature. Okay. What is what approximately we say? See, solar radiation, my friends. What is solar radiation? The solar energy that comes from the sun, you call them as what? Solar radiation. To be very precise, incoming solar radiation. This incoming solar radiation is what? In short, you call them as what? Insolation. Okay, right. Now, somewhere they say as the earth is geoid, resembling a sphere, the sun's rays fall, right? Say, for example, obliquely at the top of the atmosphere, and earth intercepts a very small portion of sun's energy. Okay. On an average, earth receives 1.94 calories per square centimeter per minute at the top of this atmosphere. Okay. That much technicality is not needed. Okay. Slowly, I'm just telling you, right? The solar output received at the top of atmosphere varies slightly in a year due to the variation in the distinction between the earth and sun. See, for example, earth as a system, if you take it, what we receive in the form of insolation, that is solar energy, the amount of energy received by earth throughout the year is more or less similar. I'm not saying same, more or less similar, but somewhere we have an exception. If you ask me when exactly you have an exception, exception happens, say for example, during its revolution around the sun. You know, sometimes, say for example, earth is located far away from the sun. Very, say for example, when I talk about this far away position, technically we call them as what? Aphelion position. It almost, say for example, occurs in the month of what? July 4th, American Day of Independence. Okay, right? And similarly, when sun is very close to earth, this position we call them as what? Perihelion. So what happens? This perihelion and aphelion time alone, the insolation will be slightly varying, right? It says, right? Therefore, the annual insolation received by Earth on 3rd January is slightly more than the amount received on 4th of July. Okay, small variation is there. See, somewhere I can correlate it. You remember somewhere when I take the cities of Australia, you find the Australian cities are very unique. In what way Australian cities are very unique, if you ask me? All these Australian cities will be located in the coastal margins. Okay, coastal margins. Why Australian cities are located in the coastal margins, if you ask me? I'll show you. Right, somewhere. See, this particular, when I talk about this Australian cities, my dear friends, Australian cities, right? They are located along what? The coastal margins as such. Okay, now, uh, why exactly Australian cities are located along the coastal margins? If you ask me, I would say Australian summers are very harsh. Okay, that's the reason the cities are located in the coastal margins. Then you may ask, what is this? Why cities located in the coastal margin may not experience very harsh summer? Very simple. Because water has the tendency to maintain temperature. Summers may not be very, very hot, winters may not be so cold. Okay, still, coastal areas you may complain that what is this temperature too hot, but you are saying it may not go very hot. Logic is very simple. If this place would have not been in a coastal area, the temperature will be furthermore higher. That's what I'm just trying to convey. Okay. Now, again, if you ask me why Australian summers are very harsh, simple. Australia, if you ask me summers of Australia, it happens in the month of December, January. Okay. Summers, that is summers. Particularly when I talk about December 22nd and the last week of December. This is the time when Australia experienced their summer solstice. Summer solstice, it means peak summers, my dear friends, peak summers. Along with this peak summers, summer solstice, January 3rd, what you experience is what? Perihelion position. Imagine a condition. Already it is summer, very hot. Along with this very high temperature, the distance between sun and earth is also very, very close. See, the distance between sun and earth is not going to make a major difference, but still a marginal difference will be there. It is something like adding salt to the existing wound. Okay, right. Right, my friends. So having said this, right. Somewhere I'm just justifying that perihelion and aphelion position alone, there will be marginal variations in the solar input or insolation. Okay, right, my dear friends. Fine. Apart from that, when I talk about the variability of insolation at the surface of the earth, right? That is, till here we are talking about the marginal variations during the different days of the year. But assume that this value is static. But there are n number of factors which makes the difference in insolation received by different parts of the world during different parts of the year. Okay. What exactly makes few places, see, few places temperature is very high, few places temperature is very less. Why exactly that variation is there, if you ask me? Because I understand that is all about insolation. Wherever insolation is more, there the temperature is higher. Wherever the insolation is less, the temperature is also less. So what are the factors which causes that variation in insolation? I'll tell you, my dear friends. Number one, the rotation. Say, for example, the amount of intensity of insolation vary during the day, in a season, and in a year. The factor that causes variation, number one, rotation of the earth. Why exactly you call them as rotation of earth? I'll tell you. Because just because earth is rotating, I have day and night difference. Day is what? You're getting exposed to the insolation. Night, you're facing away from the sun. Number two, very important, angle of the inclination of sun's rays. Very, very important. See, what is this angle? When I talk about angle, see, for example, always with respect to the surface, if I just take a surface, something like that, if I just take a surface, assume that this is a surface. Sun's rays can fall at any angle, right? Sun's rays can fall at any angle. Alright. Sun can be here, sun can be here, sun can be here, sun can be here. Okay. It can make an angle of 0 degree, can make an angle of 40 or 30 degree, can make an angle of, say, for example, 60 degree, can make an angle of 90 degree, whatever it is the case. So, sun's rays can fall anywhere between 0 degree and 90 degree. Okay. Now see, for example, you remember, right, noon. Whenever I say noon, normally we have a perception that noon means sun will be above your head. Not necessarily every time. Okay. But somewhere I'll just assume that, okay, sun above my head. Okay. But only restricted geographical location, only on a specific days. Okay, whatever be the case, they need sun position. Right? So when sun is high in the sky, obviously temperature will be very high because angle of sun's rays. When the angle of sun's rays increases, the concentration of the insolation will increase. For example, say, right? When talk about, say, for example, when angle of sun's rays increases, somewhere I understand the same energy is concentrated in a smallest possible area. When the angle of sun's rays decreases, the same energy is concentrated over a larger area. It is concentrated over a larger area. So, for example, what happens, right? That is concentration versus distribution takes place. So, angle of sun's rays plays a very, very important role. Then, my difference, length of the day. The length of the day is more. The insolation received will be more. Temperature will be more. Then comes the transparency of the atmosphere. See, when I say transparency of the atmosphere, what all I can take it? I can talk about the presence of cloud. I can talk about the presence of aerosol. If cloud is more, insolation will be reflected. If aerosol is more, insolation will be scattered. That also matters. Normally, if the pollution also means, say, for example, increases a lot, you will not find that, say, for example, sun's rays penetrating much. Okay. Transparency also is very, very important. Then, of course, the configuration of the land in terms of its aspect. For example, when I talk about configuration of the land, I'll tell you, right? Plains versus plateaus versus mountains, right? Plays a very, very important role. And here itself they say the last two, however, have less influence. Okay. What plays a very, very important role is first three. That is rotation, angle of sun's rays, then the length of the day. Okay. Right, my dear friends. I think this much, if you revolve around, it should be fair enough. And rest of it, they are, say, for example, talking about the same. And let me tell you, my dear friends, if I read this particular paragraph, spatial distribution of insolation at the Earth's surface, right? When I say spatial distribution of insolation at Earth's surface, I'll give you one statement. This particular statement which was asked this year, my dear friends, okay, or a 2023 examination, I'll show you one question which was asked. Okay, one question I'll show you. Okay, see, this is the question what I was just talking about. Okay, I'll show you what this question. Why I'm taking this question, I'll tell you. See, for example, read this. With reference to Earth's atmosphere, which one of the following statement is correct? They're asking. Okay. Now, very first statement. See, for example, arriving at a right answer, two ways I can do it. One, I read the question directly. I know that, say, for example, this is the answer. I can go for it, or I can eliminate the wrong answer. Then also I can go for the right answer. This is 2023 examination this year, May 28th. What was asked? Okay. The very first statement, they say the total amount of insolation received at the equator is roughly 10 times of that which is received at poles. I'll check whether the statement is right or wrong. Okay, see here, my NCERT information says, right? Here the comparison is between equator and poles. But if you ask me which is the hottest place on earth or hottest region on earth, is it located in equatorial region? Answer is no. It is not located in equatorial region. Interestingly, it is located in polar region. Sorry, excuse me, tropical region. Okay. So here, see, they say insolation received. Insolation received at the surface varies from about, very carefully if I look at it, see my difference, right? 320 watts per meter square in tropics to 70 watts per meters in the poles. It means roughly whatever I have at poles, tropical region has 4 to 5 times, 4 to 5x. Tropical region. Equatorial region will be having still less than that. Okay. So I understand poles versus, say, for example, when I talk about the tropical region, that itself is only 4x or 5x. Okay. But what exactly the statement says? 10x. Very, very high. Am I right? So directly I can rule out, right? Say, for example, statement 1, I can directly rule out that yes, the statement 1 is right, not the right answer. Okay. Now, one more statement also I'll show you, right? Again, if you ask me, infrared rays constitute roughly two-thirds of insolation. No, insolation is mostly ultraviolet. It is not infrared. Okay. Now, see, third statement, my dear friends, where I can take the clue from NCERT itself, right? Clue from NCERT, right? Heating and cooling of atmosphere when it comes to terrestrial radiation. Two questions were asked this year from this particular, say for example, topic alone, right? It means this particular chapter, if you would have read this solar radiation, heat balance and temperature alone, my dear friends, somewhere you would have answered, say for example, two questions this year. Okay, see here, yeah, this is the thing I was just talking about. Okay, see, atmosphere is largely transparent to short wave solar radiation. Okay, further they say, I'll zoom it, right? Should be fine enough, right? The incoming solar radiation passes through the atmosphere before striking the Earth's surface. Further, if you read it, my dear friends, within troposphere, right? Read this very carefully. They say within troposphere, water vapor, ozone, and other gases absorbs much of near infrared radiation. So one thing I understand, water vapor absorbs infrared radiation. Now you read the statement. Okay, what is asked this year? Infrared waves are largely absorbed by water vapors that is concentrated in the lower atmosphere. Over. See, words may not match directly. But only thing is that somewhere we are insisting that interpretation from the NCERT, right, plays a very important role solving the questions in the examination, right? Again, I am insisting this fact that NCERT plays a very important source of knowledge. May not be the source of question, but source of knowledge. Okay, right, my dear friends. So somewhere the topic 2, chapter 2 is also very, very important, right? Somewhere, what is solar radiation? We have an idea, right? And say, for example, when it comes to terrestrial radiation, the heat that is liberated from the surface of the earth, you call them as what? Terrestrial radiation. And my dear friends, there comes one very important topic, you call them as what? Heat budget. What is this heat budget, if you ask me? What is a budget? The balance between what is incoming and outgoing, you call them as what? Budget. What is incoming is insolation. What is outgoing is terrestrial radiation. Okay. Now, somewhere this heat budget gives you an idea that what percentage of insolation comes to atmosphere as a system or earth as a system. In that, what percentage is finally absorbed by the earth? For example, assuming instance, right? Instant, if I just take it, right? 100 percentage of insolation comes to earth as a system. Nearly 27 percentage is reflected by cloud. 6 percentage is scattered by aerosol, right? 14 percentage is absorbed in atmosphere, particularly by ozone. All right. Say, for example, in 100, 27 is gone. Okay. Or I'll put it this way, then 114 is gone, right? Remaining is 86. In 86, another 27 is gone, 59. 59, another 6 is gone, 53. What comes to earth is only 53. Out of this 53 percentage, my dear friends, again, 2 percentage is reflected by glaciers and ice caps. So 53 minus 2, what comes ultimately to the surface of the earth is 51, right? So 34 and 17 you added, I'll get 51. So it means one thing I understand, what comes to the surface of the earth, what is absorbed by the earth's surface is only half the insolation. Okay, right. And this 51 percentage has to be liberated back. 51 percentage, right? Again, say for example, this 23 plus 9 plus 19, if you add it, I'm pretty sure you should get 51. Okay, so 23 and 9, say for example 32, you get it. 32 plus 19, you get what? 51. Okay, so out of this terrestrial radiation, what is liberated back, you call them as what? Terrestrial radiation, or you call them as what? Infrared radiation, or you call them as what? Long wave earth radiation. All are same, meaning is same. Okay, and see, my dear friends, in this 51, nearly what percentage is absorbed by atmospheric constituent, if you ask me? It is 6 plus 9 plus 19. It is, say for example, 28 plus 6, nearly 34 percentage is absorbed. And here carbon dioxide plays a very, very important role. Carbon dioxide constituents is only somewhere around 0.036 percentage. But what percentage of infrared radiation, right, or terrestrial radiation is absorbed by these greenhouse gases, if you ask me, right, represented by its gang leader called as carbon dioxide? 34 percentage. This 34 percentage is not 34 percentage of terrestrial radiation. It is 34 percentage of insolation. Okay, right? What we see it as negligible is actually not negligible. Okay, right. So, for the basic facts, some of the basic facts about this heat budget also we have taken it. Okay, right. Now, once you read it, right, once you read it, they'll be saying that why exactly variations in the net heat budget of the Earth's surface also they have explained it. Okay, so latitudinal variation, altitudinal variations, right, everything they would have expressed it. Then temperature. See, one thing I know, if you read this paragraph or if you read this chapter, you will understand one thing. Insolation will heat the surface of the earth. Okay, insolation will not heat the atmosphere because already we said, right, for incoming solar radiation or carbon dioxide is a transparent gas for insolation. Already we have seen it. But the same carbon dioxide is opaque for the outgoing terrestrial radiation. Okay, Right. So one thing I understand, very important by understanding, this atmosphere gets heated up from the bottom, okay, not from the top. Because for atmosphere, if you ask me, what is the immediate source? Is the surface of the earth. Terrestrial radiation, the heat that is coming from the surface of the earth is the immediate source. Okay, it's an immediate source, my friend. This is very, very important. Right, very, very important. So I should understand atmospheric temperature. If you ask me, what is the immediate source of atmospheric temperature? It is actually terrestrial radiation. Okay. Anyway, we'll just read it. The interaction of insolation with the atmosphere and Earth's surface creates heat, which is measured in terms of temperature. While heat represents the molecular movement of particle comprising a substance, the temperature is the measurement of degree of how hot or a thing, say for example, hot or cold, a thing or a place is all. Okay, right. Now here, temperature differs from place to place and time to time. What are the various factors? Right. Number one, latitude, my dear friends. Very simple. You increase the latitude, temperature will decrease, because if you increase the latitude, insolation will decrease. Already we have taken right. Tropical region, my dear friends, 320 watts per meter square meter of an area. Polar region only 70 meters or 70 watts per meter square. So one thing, you increase, say for example, the latitude, the insolation will decrease. If insolation decreases, what will decrease is what? The temperature. Then altitude. Altitude goes hand in hand, synonym with what? Normal lapse rate. Already we have seen, right? See, for example, one place, right? NCERT, if you remember, it is given as what? You increase the temperature or height, 165 meters you increase, temperature goes down by 1 degree centigrade. But see, here same NCERT, what exactly they have given, right? For every 1 kilometer you increase, right? Temperature comes by what? 6.5 degree centigrade. Okay, right. Fine, my dear friends. Now, altitude plays a very important role. Distance from sea, continentality. I have taken the case of Australia, right? Places which is located very close to the coast, the variation in the temperature will be less. Places which is located far away from the coast, temperature will be more. Air mass and ocean currents, I can call it as wind. Either wind will be a warm wind or a cold wind. Ocean currents can be a warm currents or a cold current. Okay, so that difference also comes. Okay, then comes the distribution of temperature, my dear friends. Right, seasonally also this distribution of temperature will vary. Okay, and say for example, NCERT also talks about the isotherms. What is isotherms? Right, the line joining places having equal temperature, you call them as what? Isotherms. Let me tell you, this isotherms, seasonal variations will also be there. Okay, between summer and winter also there will be a difference. Okay, right, difference. Okay, then NCERT also talks about a small concept of temperature inversion, and let me tell you, temperature inversion is already asked in the examination. It is asked in the examination, right? Mains question they have asked. What is temperature inversion? Right? What are the different occasions where we can have temperature inversion? Very simple. What is temperature inversion if you ask me? I know what is normal lapse rate. In troposphere, you increase the height. What happens to the temperature? Temperature decreases. That is what you call them as what? Normal lapse rate. On the other hand, there are occasions where in troposphere itself, you increase the height, temperature also increases. That is the situation of temperature inversion. Okay. So temperature inversion, ground condition should be cold condition, upper air condition should be warm condition. You increase the height, temperature will also increase. Polar region throughout the year I'll be experiencing. Right? Long winter nights, cloudless night I'll be experiencing. Air drainage along the mountainous regions I'll be experiencing. Okay, so kindly also go through this temperature inversion. Okay, that's what this particular chapter talks about. Okay, right. Then going for 10, atmospheric circulation and weather system. Very important topic, atmospheric circulation. Right. When I talk about this atmospheric circulation, first comes atmospheric pressure, my dear friends. Temperature and pressure, they are very closely related. What exactly, say for example, is the relation, if you ask me, temperature and pressure generally they are inversely proportionate to each other. So normally the places where I have higher temperature, I'll be having low pressure. But Let me tell you, we do have pressure systems that is created by mechanical actions. We call them as what? Thermal indirect pressure belts. We call them as what? Thermal indirect pressure belts. Okay, right. Now here, my dear friends, when I talk about, say, for example, the pressure systems, of course, atmospheric pressure, right? What exactly is an atmospheric pressure? Even definition says the weight of the air column contained in a unit area from the mean sea level on the top of the atmosphere is called as atmospheric pressure. Very simple. I'm taking one column of air mass extending till exosphere. This air mass will be having a weight, right? Right? Whatever is the weight that is exerted over a particular place, that is what you call them as what? Atmospheric pressure. Okay, pressure exerted, weight exerted by this air column. You call them as what? Atmospheric pressure. Okay, right, my dear friends. Now, when I talk about this pressure systems, my dear friends, pressure systems, there are, say, for example, 7 pressure belts of the world. Okay, there are 7 pressure belts of the world. Okay, 4 in the northern hemisphere, 4 in the southern hemisphere, right? And say, for example, one pressure system being common to both. Okay, so what are the 4 pressure systems, if you ask me, right? So NCERT in detail, it was not talking about the same. Okay, but if you ask me, one you call them as what? Equatorial low, subtropical high, subpolar low, and polar high. Okay, so these are the pressure systems what we have, right? So somewhere it has given it. Okay, so somewhere it says near the equator you have a low pressure called as equatorial low. Okay, you have a pressure system called as equatorial low. Then somewhere 30 to 30 degree, am I right? 30 degree north and south horse latitude, you have a high pressure called as subtropical high. Then 60 to 60 degree north and south, you have a low pressure called as what? Subpolar low. And near 90 degree, you have a pressure system called as what? Polar high. These are the 4 pressure system per hemisphere we have. Okay, per hemisphere we have. Right? Okay. Right, my dear friends. Now, fine. I understand, say, for example, what are the pressure belts? And one more thing, pressure is the one which results in the, say, for example, somewhere results in the movement of the air mass or horizontal movement of an air mass called as what? Wind. Okay. And let me tell you, wind always moves from what? High pressure to low pressure, right? So that also it is explained. Factors affecting the velocity and direction of the wind. Before that, let me get it. You know that air is set in motion due to difference in atmospheric pressure. This air in motion is called as what? Wind. Okay. So ultimate reason for having a wind, if you ask me, what is the reason? Pressure difference. Pressure is a causative factor. Wind is the effect of it. Okay. Right. Now, having said this, my dear friends, wind, there are n number of factors. Say, for example, which regulates the wind. First and foremost, you call them as what? Pressure gradient force. Now, what is this pressure gradient force, if you ask me? Right. What is this pressure gradient force, if you ask me, my dear friends? A force that is created due to the pressure difference between two places, you call them as what? Pressure gradient forces. Okay. Right. Then frictional force. Very simple. If friction is more, velocity of the wind will be less. See, somewhere you would have heard about some terminologies, right? Say, for example, they say, right, roaring 40s, furious 50s, shrieking 60s. If you ask me what exactly they are the nicknames of the latitudes. They are the nicknames of the latitudes. 40 degrees south latitude, 50 degrees south latitude, and 60 degrees south latitude. They call them as what, right? The roaring 40s, furious 50s, and shrieking 60s. It means somewhere you stand at 40-degree latitude. It appears as though the wind starts roaring. Somewhere reaching this 50-degree latitude, this wind becomes what? Very, very furious. Right? And 60-degree latitude, when it reaches, almost you can hear this wind as though a child is screaming. All this fact, if I consolidate, one thing it says, right? The velocity of the wind is very high. If you ask me why exactly the velocity of the wind is very high, southern hemisphere, all the latitude, what I said, I do not have land. What is dominant there is what? Water. So when I talk about the wind which flows on water, friction will be very less. That's the reason velocity will be very high. Even jet stream, if you ask me, why exactly jet stream flows at that much high velocity? Name itself says jet stream. It is because of what? Frictional force. And my dear friends, very, very important force, very interesting force, Coriolis force. A force that is created, resulted due to the, say for example, difference, sorry, excuse me, because of the rotation of Earth. Coriolis force, most of the time it determines the direction of this wind. Okay. And if you ask me, right, what exactly is the direction? We call them as a deflective force. It slightly deflects the direction of the wind. If you're there in northern hemisphere, the Coriolis deflection is towards what? Right. If you're there in southern hemisphere, the Coriolis deflection is towards what? Left. Okay. So these are the forces that regulates the wind as such. Okay. So here the pressure and wind is also, say for example, explained in a detailed fashion. Kindly go through it. Okay. Right, my dear friends. And the general circulation direction also it is given. Okay. Right. And my dear friends, this particular topic, wind is very, very important. I want you to go through this wind, different types of wind. So based on the size of the wind, we have something called as what? Planetary winds. This particular image talks about the planetary winds. Between 7 pressure belts, we have 6 planetary winds, 2 trade winds, 2 westerlies, and 2 polar winds. Okay. So somewhere we have 6 planetary winds, trade winds, westerlies, and polar winds. Okay. So 3 in the northern hemisphere, 3 in the southern hemisphere. Okay. Right, my dear friends. Now, apart from this planetary winds, we do have seasonal winds. Say, for example, one of the finest example of seasonal winds, we have the name of monsoon, right? And Indian, when we talk about, say, for example, Indian geography, also monsoon will give a special emphasis. Then we do have plenty of local winds, my dear friends. Plenty of local winds we have. Okay. Starting from, say, for example, the cold winds, descending winds, common winds like land breeze and sea breeze, right? Mountain breeze and valley breeze, etc. Plenty of winds we have. And let me always tell you one thing. Whenever it comes for naming of a wind, one thing is there. Wind is generally named from which direction it comes from. If that is the case, my dear friends, if you ask me what exactly is a land breeze, right? We say that land breeze is nothing but a wind which comes from the land. If it is coming from a land breeze, obviously it should go to what? Sea. So wind that moves from land to sea, you call them as what? Land breeze. Then what is sea breeze? Simple. A wind which is coming from sea, you call them as what? Sea breeze. Then, obviously speaking, if I call a wind as an easterly wind, what is the meaning? It comes from the east. If I call a wind as a westerly wind, means what? It is coming from the, say for example, west. That's the meaning. Okay, right. Now I can understand. If I call wind as a southwest monsoon, it means this wind is coming from what? Southwestern direction. If a wind is coming from northeastern direction, I call them as what? Okay, northeastern monsoon is nothing but what? Wind which is coming from what? Northeastern direction. And some of such winds also it is given. Okay. And NCERT in this particular chapter also talks about one very important concept called as air mass. See, entire climatology, we actually study about this air mass. What is this air mass? Somewhere they have, say for example, mentioned it. Okay. Somewhere they have mentioned it. What exactly is this air mass? Okay. Right. Right, my dear friends. To be very precise, a three-dimensional homogeneous mixture of air, we call them as what? Air mass. Okay. Right. Right, my dear friends. Now, fine. This is some of the very important topics in this chapter. And let me tell you, since I'm also, say, for example, slightly rushing, two more topics which is very, very important. I would request you to go through, study this in this particular topic if you ask me. I would recommend you to study about this chapter called as tropical cyclones, right? And say, for example, temperate cyclones. Okay. So both the tropical cyclones, temperate cyclones, both are explained here. Okay. So kindly go through it, my dear friends. Right. So composition and structure of atmosphere we have seen, solar radiation we have seen, atmospheric circulation and weather systems we talked about. Now comes right, a very small topic, right? You call them as what? Water and atmosphere. Mostly we'll be talking about a topic called as what? Hydrological cycle. Okay. What are the topics? What exactly is that we have to concentrate here? That alone I'll tell you. See, we call them as water, hydrological cycle. How exactly water in the surface becomes water vapor? How this water vapor goes for condensation? How this condensed material once again reaches the surface of the earth? So the cycle between evaporation, condensation and precipitation, you call them as what? Hydrological cycle. So first here in NCERT, they talk about this, okay, evaporation and condensation. Okay. So what is evaporation? Simple, say for example, how exactly the surface water becomes water vapor, you call them as what? Evaporation. But if you ask me, is this evaporation is the only way how exactly water vapor is added to the atmosphere? If you ask me, no. Apart from evaporation, I also have the process of transpiration. We have a process of respiration. We have a process called a sublimation, etc. All this somewhere, right? It is mentioned here. Okay, right. Just try to understand what are the different sources of this atmospheric moisture. Once atmospheric moisture you understand, now understand what is condensation. What is condensation? This water vapor once again becoming either water droplet or ice crystals. You call them as what? Condensation. So this condensation can take place on ground, near ground or high in atmosphere. If it is taking place on ground, either you call them as what? Dew or you call them as what? Frost. So here, what is the difference between dew and frost if you ask me? Very simple. Dew is a water droplet. Frost is ice crystal. If ground condition is more than 0 degrees centigrade, I'll be having dew. If the ground condition is less than 0 degrees centigrade, I'll be having frost. Then near ground condensation, I have fog and mist. See, fog and mist is nothing but what? A near ground cloud. That's what it says. See, it says the fog is a cloud. Fog is a cloud. Am I right? With its base near the ground. That's it. Right? Fog is just a cloud. Correct? Fog is just a cloud. So, if this fog is very thick, okay, I'll put it this way, right? If it is very thick, I call them as fog. If it is slightly less in density, I call them as what? Mist. Okay? Right, my dear friends. Then what is very, very important is cloud. The most commonest form of condensation is cloud. And my dear friends, this cloud can be classified in different types. I can classify them based on shape. I can classify them based on height. I can classify them based on weather effectivity. Based on shape, I have three types: cirrus, cumulus, and stratus. Based on weather effectivity, I have a type called as nimbus cloud. That's the reason. Normally, they say cloud is classified into four different categories. Actually speaking, cirrus, cumulus, and stratus is shape-based classification, whereas nimbus is all about weather-based classification. Okay, so there is a greater difference. Okay, so nimbus is weather-based classification. So somewhere it gives you an idea what is cirrus, right? Cirrus, very fine, thin, fibrous clouds. You call them as what? Cirrus. Cumulus cloud, the most commonest cloud, right? Which almost say, for example, which looks like a cotton or a piece of cotton or a wool, right? Globular mass. Very commonest cloud is cumulus. Then I have a horizontal cloud called as what? Stratus cloud. Then, my dear friends, I have a cloud called as nimbus cloud. Nimbus is a bad weather cloud. It will be very dark or black in color, very dark. Normally, when I say nimbus clouds is the one which results in intense weather mechanism, like lightning, thunder, hailstorm, right? Even say, for example, I can put this very cloud burst, right? All this bad weather effectivity is associated with what? Nimbus clouds. Okay, right. Then finally, we'll be talking about precipitation. How? This condensed material from the sky once again means atmosphere once again reaches the surface of the earth. Right? I can talk about forms. Right? See, precipitation is nothing but what? The gravity form, the effect of gravity. The condensed material fall to the ground, you call them as what? Precipitation. If it is falling in the form of water, I call them as what? Rainfall. If it is falling in the form of ice flakes, I call them as what? Snowfall. If it is falling in the small, small crystals of ice, you call them as what? Sleet. If it is falling as a large, say for example, chunk of ice crystals, you call them as what? Hail. Okay. And we also have types of rainfall. How exactly rainfall happens, right? If at all, if the air mass rises and go for condensation and results in precipitation, I call them as what? Convectional precipitation. Convectional rainfall, equatorial region and all, it is very, very common, right? Then I have orographic precipitation. Using the slope of the mountain, If precipitation is happening, you call them as what? Orographic rainfall. Cyclonic rainfall. During the cyclones, if I have, say for example, cyclone bringing rainfall, you call them as what? Cyclonic rainfall. Okay. So that is all about this chapter. Okay. And let me take the last chapter of the day, right? Given the time, say for example, I'm just leaving these oceans, right? The world climate and climate change. Again, I understand, say for example, given the current scenario, this particular topic is very important. Okay, right. See, water movement, I'll just give you what is that you have to focus, I'll tell you, right? Why to leave it. Okay. Now here again, my dear friends, when I talk about this world climate and climate change, let me be very practical. Köppen's classification for general studies, I would say that it is not needed. Right? It is not needed. Instead of this, for examination, I would say better, you go for climatic classification that is given by G.C. Leong. See, Köppen's classification, G.C. Leong. G.C. Leong has classified somewhere around 11 types of climate. Köppen has given somewhere around 13 different types of climate. Okay. So climatic classification alone, you go for what? G.C. Leong's classification, right? One grid will be there. Okay. Only thing is that Köppen's classification, he has given, say, for example, all alphabets for classification. I feel that it is not so much needed, but kindly go for what? G.C. Leong's classification. If that is the case, right? This Köppen's classification becomes obsolete for us because it is highly technical, right? So let's not go for it. Again, I recommend that you go for G.C. Leong's classification. And global warming, my dear friends. Environment also you study about climate change, right? Because when I talk about environment syllabus for UPSC, it says, right? Say for example, almost the general idea about ecology, right? Say for example, biodiversity and climate change. Environmental ecology, biodiversity and climate change. So there also you'll be studying about this global warming. Okay. So the contemporary facts there you can take it. Okay. So with that, taking a very small clue of this oceans, water and movement of water, I'll tell you where to concentrate. What is that I have to take it important for the examination, I'll tell you. See, when I talk about water, right? Hydrological cycle, just now we have taken it, right? The cycle between evaporation, condensation, and precipitation, you call them as what? Hydrological cycle. Now, see, the divisions of the ocean floor. So, the very important features of the ocean floor I have to study. For example, continental shelf. What is continental shelf? What exactly is the very important character of continental shelf? I have to take it. Then continental slope. The outer margin of the continental crust, you call them as what? Continental slope. Then deep sea plains. Sometimes you also call them as what? Abyssal plains. Then, say for example, the ocean deeps. Okay, apart from this deep sea plains, right? The ocean deeps in the sense, mostly they are talking about what? Trenches. Okay, right. So, what is continental shelf? So, the very important features of this continental shelf, continental slope, and within the continental slope, right? If at all, if you can somewhere identify the features like submarine canyons, it is well and good. Okay. When it comes to, say, for example, ocean deeps, sometimes they are also calling it as what? Trenches. Where exactly I will be having trenches are the very important trenches you take it. And you also have, say, for example, along the divergent boundary, you have this mid-oceanic ridges and seabounds. Okay. So, what is what? Approximately you go for it. All this you call them as what? Oceanic features. Like landform features, we do have oceanic features. It means whatever lies in the surface of the ocean floor, you call them as what? Oceanic features. Okay. Then what is very important here, right? Ocean water temperature, to some extent it is important, okay, but more than ocean water temperature, what is very important is salinity. The amount of dissolved substance present in sample seawater, you call them as what? Salinity. So what I should understand, what is the source of this salinity? First and foremost, what is saline water and fresh water? I should differentiate it. What is the source of this salinity? See, for example, here one symbol is given. So people who slightly do not understand this symbol, I'll tell you, this is the symbol which represents for parts per thousand. Salinity is not expressed in percentage, it is written as parts per thousand. So what is the symbolic representation of parts per thousand? I'll tell you, right? Like percentage 1 followed by 2 0, it is 1 followed by 3 zeros. This is a symbol for what? Parts per thousand. Okay, right. So salinity is normally expressed in parts per thousand. So I should understand the source of salinity. What are the different sources? How exactly what adds to the salinity? And I should talk about the distribution of the salinity. From place to place, how exactly the salinity differs, we have to discuss about it. Okay. Both horizontal and vertical distribution of salinity, we have to take it. That is what we have to concentrate in this particular chapter. And coming to the last segment, movement of ocean water. Three things are very, very important. One is ocean waves, right? Ocean water waves, right? Number two is currents, and three is tides. But I would recommend waves also you can leave it, right? Waves you leave it. What is very, 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 very important is what? Tides and currents. What is tide? What do you mean by high tide? What do you mean by low tide? Why exactly I have a tide? Then comes what is a neap tide? What is a spring tide? I have to understand. Right? All this it is given here. Okay? Right. Tidal mechanism also I should understand. Okay. Fine. Apart from that, I should talk about very, very important. Repeatedly they ask this question in, say for example, mains examination, ocean currents. Any large scale continuous movement of ocean water, you call them as what? Ocean currents. Okay. So what is ocean currents? What are the different types of ocean currents? What are the forces which influence and sustain these ocean currents? We have to understand. And finally, I also talks about the weather effectivity that influenced by ocean current. For example, see, now also we are talking about El Nino. You ask me what is El Nino? El Nino is all about disturbed ocean currents. Ocean currents plays a very, very important role in determining the weather pattern of a particular place. So somewhere I have to concentrate on that. Okay. So the very important ocean currents I have to take it for my discussion and I have to read it. Okay. So right, my dear friends, with this, we'll just conclude today's class. What is very important in each and every topic of NCERT, approximately I have told you, right? You can take it and somewhere you can concentrate on those areas. Repeated revisions. Repeated revisions is very, very important. Right? So rest, we'll take it in the class to come. Right. So till then, thank you and God bless.